In the previous video, we looked at several ways to improve the usefulness of our breakpoints. In this video, we're going to take our LLDB debugging skills to the next level by learning some LLDB commands, which will allow you to print values, navigate breakpoints, and even manipulate session variables. Believe it or not, everything that we've done already, from creating breakpoints to applying conditions and actions, can be done by using LLDB commands in the prompt window on the right. In this video, we'll go over some useful commands and see where we can discover more. Let's open our project and remove any existing breakpoints. We'll add a simple breakpoint that'll fire when our application hits our val variable inside of our for-in loop. So build and run, and we'll immediately hit our breakpoint, and our session will attach to the debugger, which gives us access to the LLDB prompt window. The first command to try is the help command, which gives us a list of all of the commands available to us. This is helpful, of course, for learning new commands, or for when we need a reminder of what a particular command does. As we scroll through the list, we see the same navigation commands that are available to us in the LLDB ribbon. We see C and also continue, two ways of continuing from a breakpoint. Let's test some of the flow of control commands that help us navigate through our debugging session. First, we'll test continue, or C for short. If we enter C into the LLDB prompt and hit enter, our loop cycles once and breaks on the next iteration. Let's try step over next, which is also alias to next, or just N for short. Type N in the prompt. We can repeat this a few times and we'll step through our loop. We also have a step in command, which allows us to step into functions like before, and the step out command, which allows us to step out by advancing our application to the nearest return call. We can also print variables that are in scope with the print command. We can print out the current value of our val variable by typing pval and pressing enter, and we see our current value printed to the console. We can actually print out anything in our class. Stop the debugger and let's create a dictionary at the class level with some arbitrary data. Let's name it myObject and just give it some arbitrary values. Build and run the application again, and when the program breaks, enter print_self.myObject into the LLDB prompt and hit enter. We'll see our object printed out just as LLDB sees it. It's important to note that any value we see with a $sign in front of it can be printed like a variable. For instance, if we print out this $R value from here, we'll get the exact value printed out. We can also print functions. For instance, entering print_self.breakpointTest prints out our function's type signature, takes void and returns void. And we can even print self to see the contents of our current instance. You can modify values on the fly by utilizing expressions. We can set our val variable to whatever integer we like by typing expression val equals 99, for instance. Then we can print out our variable to see the newly assigned value. We can even add two variables together to create a value, like this. Expression val equals 99 times $R2. Printing this will show the product of our assignment. Now, this is just an introduction to the LLDB commands. There are too many commands and use cases for commands to cover them all here, but I encourage you to check out this video's resource page, where I'll share some additional examples of LLDB commands, as well as some excellent resources. In this video, we have introduced the topic of LLDB commands and improved our debugging skills. In the next video, we're going to take a look at address sanitization while working with Objective-C or C.